Hello guys, welcome to a new video. And in this video, as you can see guys, I have added two more routers over here, and I also added some IP addresses. It looks a little bit confusing, but it all gonna make sense as soon as I start configuring and plugging in all the cables where they go. And in this video we are going to do some AAA configurations, and I believe we are going to do some HSRP for redundancy with these two routers. And I believe, let me see what else we are going to do. So HSRP AAA, which is for accounting, authentication, and authorization, something like that. I know they are those three. So we're going to talk about that: AAA, ACL, and HSRP. So we are going to configure all that in this video. And as you can see, I have added these two routers, this switch, and these two servers. And if you haven't seen my other videos, just go ahead and watch my other videos where I created a GRE VPN tunnel. I did some Ether channel, configure these routers using ERP, did some port fast, PPDU guard, and a lot of more stuff. So go ahead and watch my other videos if you guys haven't watched it, so you can start from there. And I also am going to add this package tracer activity on the description below, so you guys can download it and follow me on this configuration. Okay guys, so let's go ahead and get started. And actually we are also going to be doing some PvP as well. So PvP, all that good stuff. So let's go ahead and turn this bad boy off, plug that in, turn it on. And what I'm doing is I'm just adding some serial links so we can have some serial links interfaces. Gonna have to turn this one off for now, add it, turn it back on. Alright, so first of all, what we're going to do is let's go ahead to the switch 5. Make this bigger, like always. I always forget that this doesn't save my configuration. That's good for now. Alright, let's go ahead to switch 5 again. Enable. Let's give it a host name of switch 5. And let's do show IP interface brief. And let's shut down all the interfaces. So from 1 to 24 interface range, from 1 to 24, and then from gigabit 1 to 2 shut down, right? Let's see, from 1 to 24 shut them all down. Alright, that looks a little bit better. So now sorry guys, let's go ahead and what we have to do, go to exit, go to interface faster than 1. Yeah, 1 to 2. Let's do range. Go switch. Let's just leave it like that for now. We're not gonna do any VLANs or anything on this switch. But we want to, let's see. Let's see how can we do that. Let's switch. Not switch port. Let's do a spanning tree. Port fast, spanning tree, PPDU guard, enable. And then let's plug these two servers in. 1 and 2. And let's do a no shutdown. There we go. So that's working. that's good. Also, let's go ahead and from over here exit. That's good. Let's go ahead to router router 5A. Enable. Config T, host name R5A, interface, let's do gigabyte 01 or gigabyte 00, and from there what we are going to do is we are going to configure an IP address 192.168.30.2/24, not shut down, and then let's go to interface serial link 031 IP address 192.168, or not 192, 10.10.70.1, which is this one right here, /30, now shut down. Let's go ahead and go back to this interface, and on this interface we're going to add what we call that HSRP, or hot on standby routing protocol, and it's going to be 10.10.10.10. okay, and what hot on standby routing protocol does is that it's going to have this IP address for both of the routers. Both routers are going to have this IP address right here, and what it's going to do is we are going to add router R5 to be our active router. So if this interface is up, all the traffic is going to go through R5, but if R5 goes down, then R5B, which is going to be on standby, is going to become the active interface because this one is down, and then all the traffic is going to go this way. Okay, but if this interface comes back up, then all the traffic is going to go back this way. Okay, so we're going to add some redundancy with hot on standby routing protocol. So let's go ahead and do that. Standby 1 IP address 10.10.10.10.10. Standby 1 priority 110, because the default priority is 100, and the higher the number, the higher the priority. So 110 is good. And now standby 1 preempt, and what this means is that if this interface ever goes down, then this one is going to be the active, but if this one becomes available again, then this one is going to be the active interface again. That's what preempt does. Alright, so that's good. It's all configured for now. Now let's go to R5B and configure that. Config the host name R5B, interface gigabit. I believe I put 00 for this one. Yep, 00. IP address 192.168.30.1. 245.245.245.0. Now shut down. Now let's do is standby 1 and IP address 10.10.10.10, which is the same IP address as R5. Okay, and we are going to leave everything as a default. The default priority is going to be 100, and since this one is 110, the R5A is going to become the active router. Okay, so now let's go ahead to interface serial link 030, IP address of 10.10.60.
Here's your reminder. Put the wash into the dryer.
Okay, and that was a reminder for me, if you guys heard that.
Here's your reminder.
1 second.
Put the wash into the dryer.
Okay, sorry for that, guys. It was just a reminder from Alexa. 252. So IP address 10.10.60.1, 205.205.252. No shutdown. So we have configured this interface over here, and okay, so this is good. For now, we can leave it like this. Let's go ahead and plug these bad boys in. This one is going to be on 3, and this one is going to be on 4. Alright, let's do no shutdown. Oh, we did for interface no shutdown. Alright, is this one connected to that interface? Let's see. Gigabit 00. What if we plug it in? Oh, the issue is that here interface fast Ethernet. Where is it? This interface is shut down. 04. Because I remember I shut down every interface on switch 5. Now let's go to 3. No shutdown. Alright. So this is good. Looking beautiful over here. Now let's go ahead and plug this 2 bad boys in. This is going to be 031. And this one is going to be 030. Okay, and who's going to be doing the clock in here? Let's see. Okay, I want actually one router 3 to be doing the clocking for both of them. So 031, 031. Let's go to router 3. No. Config T interface 030 IP address 10.10.60.2 252. No shutdown. Let's go and do clock rate 64,000. Let's go to 031. 031. IP address 70.2. And the clock rate. No shutdown. There we go. So this is good. I see that these 2 interfaces are down on router 3. Let me do an show run. I think I messed up the configuration on this router when I turn it off, and then yes, I did. So let's go ahead and do that again. Config T interface gigabit 01 and IP address 10.10.20.2 252. No shutdown. Let's go to interface 00. This one is going to be 30.1. No shutdown. Router HSRP 10 network 10.10.10.20.2 10.10.10.30.1. Okay, and then let's also add 10.10.70.2 and 60.2. Alright, so this is good right here. I just messed up the configuration when I turn it off to put in these serial interface right here. But now it is good and it is working the way I want it. And so R3 is good. Let's go ahead to R5. And as you can see right here, this one is a standby. For the hot standby, you see HSRP standby routing protocol, and this one is the active router for that. And you can see that by doing a show standby brief. You can see, make it bigger, you can see interface gigabit 00. The group is 1, priority is 110. It is the active interface. It is, where is the active router is locally, because it is itself. The standby is on this IP address, which is this one right here, and the virtual IP address is 10.10.10.10. If you go to RB, show standby brief, and we can see that it is on interface gigabit 00, group number 100, priority, which is the default 100, and the state is on standby. Where is the active? The active is on this address, which is this one right here. Who is the standby router? The router is locally. We are the standby router, and the virtual IP the same for all of them. Okay, so now let's go ahead to config T, router EIGRP 10, network 10.10.60.2. Is that what it is? 60.1. Okay, and then let's add 192.168.30.1, and now let's also add EIGRP on this config T, router EIGRP 10, network 10.10.70.1, network 192.168.30.2, and as you can see over here, oops, let's go back. So I have added this EIGRP networks because I have configured my entire network using EIGRP, and if you haven't seen my videos before, you might get a little bit confused of why I'm adding and using EIGRP, and that's because I have used EIGRP on all my routers. Okay, so if you haven't watched my other videos, I think my past 3 videos, you should go ahead and watch it. Otherwise, you are going to be lost on what I'm doing, or since I'm not explaining a lot, you might get lost. Okay, so HSRP is up and running. Let's go ahead and configure. Let's go ahead first and configure the server. Let's go ahead to, we're going to configure IP address 192.168. What is it? That 30.30.4. The default gateway is going to be 10.10.10.10. And why is that? Because that's the IP address for HSRP, which is the one that we're going to use. We are not actually going to be using this 30.2 or 30.1. We're going to use this one, 10.10.10.10, because both of these routers are using HSRP and doing some redundant, using this HSRP to be redundant, right? To add redundancy to the network. Okay, so that's good. Now let's go ahead to AAA 192.168.30.3, 10.10.10.10. Okay, and now from any of this, let's see, from the server, let's go ahead and ping this network over here, ping 192.168.10.5. There it is. So I'm able to ping this network over here. Let's go ahead and do the same from this website. Ping 192.168.10.5. 10.5. There we go. We're getting a reply with a little bit of a delay timeout for some reason. Go ahead and do it again. There it is. Go ahead and do it again. Alright, so this is working correctly the way I wanted it. And if you do a trace search 192.168.10.5, what you're going to see is that we're actually sending it via R5A, because this is the active router for 10.10.10.10, right? If you do it again, it's still going to send it this way. So it's not really doing the load balancing, it's only sending it via this way. Let's try it again. There you go. But what happens if this interface goes down? Which way is it going to send it? There you go. So now it's going to send it via R5B. It's going to send it via R5B, and that's because this interface is down, and this one, as you can see, became the active hot standby routing protocol. But if this interface becomes available again, and we do this again, and now it's going to send it back to R5A, right? Because this one became the active interface again. So this one became the active routing hot on standby routing protocol, right? Because I put that preempt in there to make sure that if this one comes back up again, this one becomes the active again. Okay, so hot on standby routing protocol is working correctly the way I wanted it. Now what I want to do, let's go to desktop and go to services. HTTP is on. So let's go ahead to the index, delete all that, and since I know a little bit of HTML, let's go ahead and do H1. Close it, H1. Welcome to CCNA.com. Save it. Yes. So from this computer, let's try to go to this website, the server, which is 192.168.30.4. There we go. Welcome to CCNA.com. So that is working correctly the way I wanted it, right? So since that is working good, also let's go ahead and try it from PC9. Let's go to website 192.168.30.4. There we go. So that is working correctly just the way I wanted it. But we are going to configure an ACL, which is a access list. And what we're going to do on this access list, we are only going to allow this network over here, 192.168.10.1, to have access to this server, but they should be able to ping or do anything else. Okay, so one way to do this is by we are going to create an extended access list, and an extended access list needs to be as close as possible to the source. So as close as you can put it to the source as possible. So we're going to put on router 3, right? Enable config T, so access list 100, and let's see what we're going to do here. We want to deny, we just want to deny. What do we want to deny? We want to deny TCP, right? And what is this? The source. Actually, we have to put it as close as possible to the destination. That's how extended access lists work. So as close as possible to the destination. I said as close as possible to the source, but it is to the destination, I believe. Yeah, that's how it is. If I'm mistaken, go ahead and correct me and leave me a comment below. So let's go ahead and create access list 100, deny TCP. And what is the source address? I want to deny anybody coming from 192.168.20.20.0 using a wildcard mask of this. Okay, and what's next? Now we need to put the destination IP address, which is going to be 192.168.40. Is it that 40? No, that 30. That 30.4. And the wildcard mask is going to be all matching, right? And what do we want to do here? Equal to www. Okay, and there it is. And then after that, let's do access list 100 permit IP any. Alright, so that's good. And we add this because after you create an access list, after that happens, it creates a access list 100 denied any. So that's why you have to tell it to permit IP any. Okay, so now let's try this. Let's see if we are still able to access it from 192.168.20.1. Actually, we have to add it to the interfaces, right? Interface gigabit or serial link 030, and let's do access IP access group 100 and going out. And let's do a 4031 going out. Now, since they're placing the interfaces going out, let's see if we're able to access that website again. 192.168.30.4. Okay, it looks like we're not able to access that website. Let's see if we are able to access that website from this network. There we go. We are able to access it from this network, but we're not able to access it from this network. And that's because of the access list that I created. It's working perfectly. Great. Now let's see what else. We only told this router actually to only block HTTP packets, so packets going to the website. So we still should be able to ping from any we should be able to ping from anywhere. Let's see if that passes through. So yeah, it's not even letting me ping this. Are we able to ping from here? Ping. Oops, ping. So we are able to ping from here. Are we able to ping? That 30, that 4. Yeah, so we're not able to ping from here. Let's do and show access list 100. So deny TCP from 192 equals to www. Interesting. I permit IP any. That's interesting. Well, it should be working, but for some reason it's not working. So what are we going to do next is that on the next video we are going to fix the access list to make it look or to make it work a little bit better, and we're going to do some AAA configuration as well. So if you guys want to tune in and wait for my new videos, go ahead and subscribe to my channel. Also follow me on Twitter if you have a Twitter account. If you don't have a Twitter account, go ahead and open one, and still follow me at CCNA Daily Tips. Thank you guys for watching, and I'll see you in the next one, guys. Bye bye. I love you all.